Level Geography Ravers, hello. This video is going to look at 5.3 B and C in the spec, alright? Which will be the end of Key Area 1 when we finish this, so happy days, folks. Right, what are you going to learn then? Well, the first part, anything in blue, is going to be all about river regimes, and the second bit, 5.3C, is all about storm hydrographs. So what are you going to learn? You're going to learn what a river regime is, the three different types of river regimes, and we're going to have a look at some graphs that show very different river regimes. What factors affect river regimes, so physical or natural factors, and a couple of human factors as well. And then the stuff in red, what is a storm hydrograph? We're going to label its component parts and maybe think about why they're useful as well to planners and other stakeholders and key players. Keywords, if you want to jot them down the left hand side of your page or however you want to do it, they're there for you. Let's do it then. Here we go. Right then, so what is a river regime? Well, simply put, it is the annual variation in discharge or flow of a river. Alright, so how does the flow of a river change throughout the year? Alright, these are normally always annual from January to December. Discharge, I've just put that on as a keyword as well, because if you don't know what discharge is, then you're going to struggle to kind of understand what river regimes are. Discharge just means the volume of water flowing through a river channel at any given point or measuring station. Alright, and we measure discharge in cubic meters per second, or otherwise known as QMEX. Alright, now we are going to have a look at a selection of different river regimes, and one point to note with these is if you Google maybe like river regime for the River Nile or the Amazon, whichever river regime you Google, always take a look at where the measuring station or where the point is, if you like, on a map, because that can make river regimes look very different for the same river. Alright, so obviously you can have a measuring station near the source of a river, you can have it in the upper course, the middle course, or the lower course, and that'll show often very different results. So that's the first thing if you do decide to go and research a few yourselves to be aware of. Now, there's three different types of river regimes. So an even regime is where the flow of the river and the discharge of the river doesn't really change throughout the year. Alright, so it's constant, steady. You could use those descriptors to describe it, and we'll have a look at a couple of those in a minute. A simple regime is where a river experiences seasonally high discharge followed by a low discharge. So your graph will look, it'll have one big peak and then it'll decrease quite often, or one drop and then one increase depending on the season. A complex river regime tends to be for the world's major rivers, where longer rivers cross several different climate zones, travel through different types of relief from mountains to lowlands, and because of that they tend to experience different seasonal and climatic events. Alright, and often human factors as well tend to play a part in influence these rivers, because they tend to be that long, that large, have a high discharge throughout the course. So take a minute just to tidy up and define them keywords before you move on. Alright, right then, before we actually look at any of these regimes that I've got on my slide, I've just pull up a table and look at it. Kind of links on from last lesson with positive water budgets and runoff and things like that. And if you look at Let me bring this to front one sec. Yeah. If you look at the world's list of rivers by discharge, so which rivers discharge the largest volume of water, you can see number 1, the Amazon, largest drainage area, got the largest drainage basin of any river in the world, and by far and away the highest average discharge throughout the year. Yep. So on average, the Amazon discharges 209,000 meters cubed every second. All right, 209,000 meters cubed of water every second. And then you can see the list decreasing in this column. Yep. And if you just do a bit of a tally, you know, what continent do we find the rivers with the largest discharge, and just do a tally, and, you know, for South America in particular, well, the Amazon, which is by far and away the one that discharges the most. So 1, the Orinoco, 2, 3, 4, 5, 6, 7 out of the top 12 rivers by discharge are found in South America. Lovely bit of evidence to prove that it's very rainy and has a lot of inputs in South America. And then if you have a look at the second continent which pops up, Asia, 1, 2, 3, 4, 5 out of the top 13. Yeah, okie pokey. So that's worth bearing in mind. Okay, folks, now 90% of the time, most of these river regimes will be shown as a line graph. Alright, sometimes you might occasionally come across one as a bar graph, which is fine. So this is a river regime for the River Severn in the UK, and if we were to describe this, then we'd say that in winter time rainfall levels are higher, discharge decreases in summer, and we can assume as well that evaporation rates increase, so the outputs increase, and then it rises again in winter. So the River Severn is an example of a simple regime, yep, where it experiences a seasonally high discharge in kind of autumn and winter, and then it's got a lower discharge in summer, and that's typical for a lot of rivers in the UK. Alright, so if we pull up a few others just at random, let's have a look. Blue Peter style, here's one I did earlier. No idea which river this is for, but again, you know, if we're going to describe this, if you got this in the exam, it'll normally be location based. It will tell you what the name of the river is probably, and where you find it. But if you're blind like this, what type of regime is it again? This is a simple regime, got lower discharge from January to April, suddenly rises and then falls. What I want you to do is just pause the video a second, just think. You've got no idea where this river regime, what river regime this is for, if you like. Just want you to think what might cause this seasonally high kind of spike or increase in summer months. All right, just have a think. Couple of possible answers that I might be expecting you to get. One is it could be an increase in inputs or precipitation, maybe from a monsoon season, something like that. Another possibility you might have got is if snow melt and glacier melt tends to increase in summer, so that might cause a higher input into the river channel and a spike in the discharge. Alright, which would make sense as well. Right, folks, this river regime, again, it doesn't actually tell us the river, which is fine. We can still kind of analyse it. And this is very nicely labelled for us as well, with kind of a description of the flow. So, winter flow between January to April, or March if you like, very low very low flow, and then you can see this kind of huge steep spike where discharge increases due to snow melt, summer flow increases, and then it decreases again. So again, this would be a simple regime. This river regime is from the Mackenzie in the Arctic Circle. Again, winter, yep, really kind of low discharge levels. If you can think about why that might be, that'd be fantastic. And then summer, again, increases. Now this one has got kind of, it's from 1973 to 2011, so each one of these coloured lines is a different regime for that river. And then they take all the regimes over the last, 30, 40, 50 years, however long it is, and plot them in a different colour, so you can see kind of the variation year on year. Yep, so don't let that confuse you either. Each one of these coloured lines is just a different year. This is an interesting one. The River Murray in Australia. If you look at this line, then that shows the long-term average. So it doesn't tell you how far it goes back time-wise, but you can see the Murray used to have a simple regime, and it used to increase in summer when it was receiving rainfall, but something's happened since the start of the 21st century. I mean, this figure is for 2006. It's dropped significantly to a even regime, and then 2007 it's basically dried up. I think this is from a newspaper clipping, so dry as a bone was the headline. Right then, so what factors affect these regimes? Well, the first one is pretty self-explanatory, the amount of rainfall that falls in a drainage basin. And linking back to previous lessons, the type of rainfall, is it snow or rain, for instance, the amount that falls, whether that rainfall is seasonal and only comes in certain months of the year, and its intensity. Second one is climate, which climate can work a couple of different ways. One, in summer months, glaciers, snowpack can melt, which increases discharge because it runs off into river channels. But also in summer months, in warmer climates, outputs and losses and evaporation from the drainage basin and the channel can increase as well, lowering flows, if you like. Key point in winter, in kind of really cold Arctic environments, your flows within the drainage basin and river flows tend to be on go slow, because if any precipitation does fall, it falls as snow, which is a solid and doesn't end up in the channel. And also your actual river channel itself can freeze, so that can decrease your discharge. Geology and soils. This is an interesting one, because if your drainage basin is kind of impermeable geology, and it's igneous, metamorphic possibly, and it's not porous, then your runoff is going to be a lot more responsive to rainfall, alright? Because it's not actually infiltrating and percolating into the kind of bedrock under the catchment. On the other hand, if your geology is porous and permeable, for instance, like under the Thames, a lot of that catchment is chalk, then even in times of drought, there's still kind of a base flow and groundwater flow that tops up the river channel and the discharge. So if you go to the Thames when it's not rained for 3 or 4 months, you might think, well, why is this river, and why is it not dried up? And your answer is it's being recharged by groundwater flow. Alright, very slowly. 4 is vegetation type and cover. Again, vegetation, large forests and wetlands, for instance, tend to keep river flows nice and steady. For instance, wetlands can hold lots of water and release it slowly into the river in times of drought, for instance. So porous and permeable geology and lots of vegetation and wetlands tend to keep river regimes nice and steady. You're more likely to get an even regime in that case. And the fifth one is the length of it. Now, what I mean by this is if you've got a river that flows through different climatic zones, different relief, also it's more likely to be affected by human factors because it's longer, then it really does matter where you take the reading. If you measure the discharge near the source, it's going to be very, very different to if you measure the discharge of that river near the mouth. So, word of warning, think about what part of the river you've actually measured the discharge and the flow. Yep. Human factors, there's one big one, and that's why I've put it in a bigger lettering, if you like, is dams. If you block off a river channel, obviously stream flow, channel flow downstream is severely reduced. So if you ever see a river regime where it just kind of falls off a cliff and the chances are it's just downstream from a dam. Yeah, so where you place your monitoring station is very important. The other thing which is affecting river regimes in certain parts of the world is enhanced global warming and climate change. And we'll look at that a little bit later on, alright? Books, where river regimes are all about what affects the flow of rivers and the discharge of rivers over the course of a year, a storm hydrograph is more concerned with on a day-to-day, more short-term basis. And the definition of a storm hydrograph is showing how a discharge of a river changes over time in response to a storm event or a rainfall input, if you like. Alright? Now, in my students, in your booklet on page 21, you have got this picture of a storm hydrograph in your booklet. So all we're going to do is I'm going to talk you through the different components of a storm hydrograph. You need to be familiar with them in time for lesson and write in and label and follow me as I talk you through it. First thing to kind of label is, because there's two axes, which is the first thing that can throw people kind of all to cock. And the first thing that we want to look at is the bar graph. Alright, now the bar graph coincides with the rainfall in millimeters. So that is your storm event. Your storm event is shown, or your rainfall event is shown by this bar graph. Yep, so it started raining, peak rainfall, where rainfall is the highest, is at this time, if you want to read off the scale, because time is on the x-axis. So that shows when rainfall was at its highest. We call that peak rainfall. Quite explanatory. The line graph and everything after it in the the green line and the blue shaded bit is how the river responds. And you'll hear me using this word. How does it respond? Rivers respond over the long term, and we show that on a river regime graph. But also rivers respond over the short term. And a bit of a kind of hazard warning here, folks. Do not get river regimes and storm hydrographs muddled up. They show different things, alright, or over different time periods. That's the first thing. So, where is the discharge the highest? If we look at the line graph in QMX and we use this axis, well, peak discharge is this point here, alright. When the river responds and the discharge starts to increase and it rises, then we can call that the rising limb. Yep. So this bit of the graph is the rising limb, where the discharge of the river is increasing. Well, if that's the rising limb, then logic tells us that this part of the line must be the falling limb, alright, when the river flow's kind of getting back to normal. And I've labelled it in the wrong place, folks, which you're going to curse me for in lesson. Sorry, yeah, got me labelled in the wrong place. Yeah, so this is the rising limb. The lag time, you might want to make a note of this, is the time difference, how long it takes from peak rainfall to peak discharge. So it's this time between the two. Yep. So lag time is peak rainfall to peak discharge. Alright. Your risk of flooding is obviously going to be highest when the discharge of the river is highest. So risk of flooding is highest more or less at peak discharge. Yep. The base flow is water that kind of makes its way into the river channel through soil through flow and groundwater flow. So it's fair to say, folks, that the base flow isn't that affected, or definitely not as affected as much by your rainfall event. Alright, the bit that is affected is your storm flow, which is all this shaded area just here. Yep. So, bit of a recap. Peak rainfall event is the bar graph. How the river responds to that rainfall event is the green line. The time difference between the peak rainfall and peak discharge is called the lag time. How quickly the river responds and increases its discharge is called the rising limb. This can be very steep or it can be more gentle. Your risk of flooding is the highest when the discharge is the highest, and the base flow is the flow that's not affected that much by your peak rainfall event. It's still affected a little bit, but nowhere near as much as your kind of overland flow and your surface runoff that makes its way into the channel. Alright, folks, just double check and have a reread of all the information on page 21 in your booklets. Label this graph, make sure you're familiar with what the labels mean. I want to be testing you in lesson next. Alright, folks, bring a good set of notes to the lesson. Take pride in what you do. Alright then, Jedi Geographers, have a good one. Ciao.